The ExoMars Schiaparelli lander is designed to demonstrate technologies for entry, descent and landing. Every aspect of the mission and the lander's performance will be carefully monitored by sensors on board. Because landing on Mars is tough, particularly as this will be the first mission to attempt to descend through the atmosphere during the planet's dust season. The lander is heading for the Meridiani Planum, an area that's currently being studied by NASA's Opportunity rover and Europe's Mars Express. Schiaparelli separated from the Trace Gas Orbiter on the 16th of October and will be activated a few hours before reaching the Martian atmosphere. The lander will be travelling at some 21,000 kilometres per hour, and the front heat shield, covered with 90 insulating tiles, will be subjected to temperatures of up to 1,500 degrees Celsius. Temperature changes will be monitored by an instrumentation package. 11 kilometres above the surface and slowed by the heat shield to around 1,700 kilometres per hour, the parachute will be deployed. 12 metres across, it is based on huygens used by ESA's Huygens probe for the successful Titan landing. 4 minutes after entering the atmosphere and now descending at 320 kilometres per hour, Schiaparelli will release the front heat shield and turn its radar on to assess its position above the surface. Just over a minute later, after jettisoning the parachute and rear heat shield, the module will activate its thrusters, slowing down to less than 7 kilometres per hour. Finally, 2 metres above the ground, the engines will switch off and the lander will drop to the surface. The shock will be cushioned by a crushable structure built into the module. Once on the ground, because it's powered by batteries, the probe has only a few days to complete its science mission. The science payload on board, called DREAMS, consists of a suite of sensors to study the environment. It will measure wind speed and direction, humidity, pressure and temperature, as well as the transparency of the atmosphere and atmospheric electric fields. The lander is also fitted with laser reflectors, which will be used by Mars orbiters to help locate the lander. Although its mission will only last a few days, Schiaparelli will provide vital information to help make Europe's future missions to Mars a success. The structure and composition of the South Polar ice cap and discovered auroras. It has also made the closest ever flybys of Phobos, one of Mars's 2 moons. But it was the discovery of methane in the Martian atmosphere that made the most impact, as this methane could be from geological activity or it could be a byproduct of life. The ExoMars 2016 Trace Gas Orbiter will carry 2 instruments capable of studying the distribution of methane in the Martian atmosphere. So far, India's orbiter, which recently released its first science results, has not found any methane on the planet. The planned ExoMars 2020 mission will bring Europe's first rover to Mars and, combined with the Trace Gas Orbiter, will help us to fill in the gaps in our knowledge, whether it's about electrical processes in the atmosphere today or the history of water on the planet. In the mid-1970s, NASA's 2 Viking spacecraft landed on Mars, specifically tasked to search for life. They couldn't provide conclusive evidence, but the joint European and Russian ExoMars program will be the first mission since then with this aim. In the past 20 years, a network of orbiters has grown up around Mars. NASA's Global Surveyor, for example, has been in orbit mapping Mars since 1998. Joined by Mars Odyssey in 2001 and the MAVEN mission in 2013. Even spacecraft that have completed their missions, such as India's Mangalyaan, remain in orbit, available to the growing network. They also assist other missions. As ExoMars approaches the Red Planet, its older sister, Mars Express, will provide a vital communications platform during the complex landing of the Schiaparelli probe. In addition to its scientific mission, the ExoMars Trace Gas Orbiter will become a relay and communications platform, providing the link between Earth and the 2020 ExoMars rover. International cooperation is key. The Big Six work together. ExoMars itself is an embodiment of that cooperation, ESA and Roscosmos fully collaborating on a specific mission. ExoMars' Trace Gas Orbiter, seen here shortly before launch, is a science mission and also a communications relay for future rovers on Mars. The orbiter will sniff out methane and other gases that are present in small concentrations in the atmosphere. Methane is particularly important as it could be evidence for biological or geological activity. The orbiter's first role is to deliver its Schiaparelli lander to the Martian surface, recording the lander's signals during its descent. As the lander approaches the surface, the orbiter will be making its own critical manoeuvres. These included an engine burn for around 134 minutes on October the 17th, 12 hours after separation. This was to raise its trajectory into an orbit several hundred kilometres above Mars to avoid joining its lander on the ground. Another critical burn that will happen today will slow the orbiter down to be captured by the planet's gravity for Mars orbit injection. During 2017, the orbiter will adjust and decrease its orbit by aerobraking, letting the atmospheric density slow it down as the solar arrays generate small amounts of drag, until it reaches its final science orbit. There are 4 science instruments on board, including 2 from Russia, the Neutron Detector FRIEND and the Atmospheric Chemistry Suite ACS. FRIEND will map hydrogen and reveal deposits of water ice near the surface, while ACS will complement the 3 spectrometers that make up the European NOMAD instrument. The other European instrument is the Colour and Stereo Surface Imaging System CASSIS, which will take high-resolution images and provide context for any detected gases. NASA has provided the orbiter with a radio relay capability, a telecommunications package and navigation aid for links between Earth and a rover or lander on Mars. The Tracegas orbiter can provide data relay services to NASA's rovers and also ESA's ExoMars rover, which is set for launch in 2020.
That we will hopefully see any time soon. So here we have the successful
confirm separation from Doppler data.
Separation. There we just heard.
Good separation from the Schiaparelli module, and the TGO signal has been reacquired.
And that was last Sunday, of course. You saw the date down there. We always
from
hear
the Doppler plot that we can see on the barcode in the middle of the room. We can confirm that the maneuver has started.
And that was Michel Denis just a couple of hours ago, a successful Mars orbit insertion. So, we have 2 good news for you already, which happened in the last few days and in the last few hours. And here we have the wake-up of the EDM lander.
It's very faint, but it can be observed on the Pioneer radio telescope picture.
There you see that needle in the haystack there, this very thin line that we should see now, which gives us, is the signal that we reach also from Pune in order to tell us that the lander woke up in order to start the descent, and we're still waiting for this signal. What is it we see right now here?
So this is our antenna that is tracking a signal, a radio signal. We're tracking, observing potential radio signal coming from Mars direction. For the time being, we absolutely see nothing. What you see there is just the noise generated by the fact that there is some temperature, if you want, in the receiver. So this is like when your radio is not tuned on any frequency, you just hear noise. This is exactly what we are hearing now from Mars. As soon as the ExoMars, the TGO, will point the eigenantenna, which according to the time I read there on the screen should be a matter of a few seconds actually, then we should be able to say that the TGO. What happens on board the spacecraft, the radio frequency is now switched to the eigenantenna. During the maneuver itself, we were transmitting with the low-gain antenna, so a much weaker signal, and the spacecraft is moving in an attitude, moving the antenna in a position that can point to the Earth. So this might take a few seconds.
Okay. So now...
Silence, but I see something happening there.
Yay!
Yay!
Yes! OS. Very likely, even more likely than before, we have 2 satellites around Mars. This will need to be confirmed, but this is really what we were expecting at this time.
Okay, Michel Denis, flight director, we could hardly understand a word because the applause in here was so roaring, but I'm sure Andrea Akumatsu completely understood what you were just trying to tell us.
Well, I can imagine what Michel said. I was very happy to see him talking. So it means we are alive.
Michel, are you still with us or are you busy?
Yes, go, Monica. I hear you.
Okay, just tell us the good news one more time.
So, yes, we saw at the time we expected the carrier signal and the telemetry coming on our stations and on the DSN station. And from the timing, it looks very coherent with a good capture. Needs to be confirmed in 2 hours by Flight Dynamics detailed analysis, but it looks already very, very good for the TGO mission around Mars. So I'm moved.